We've already sketched sine and cosine functions, but this time we're going to do them with translations. There's a number of notes here, but the key note to understand is this one here, that when we're graphing y equals cosine 2t plus pi on 4, we need to note that that translation is not pi on 4 left, okay? It is not that, okay? And the way to think about this one is y equals, I've forgotten to write down cosine there, but y equals cosine 2 brackets t plus pi on 8. This is in fact a translation pi on 8 to the left. Okay, and so I've just noted there you might find it easier to see the horizontal translation of pi on 8 units to the left in the second as opposed to the first. Okay, now there's a couple of other things that you can use here to work out the A value and the C value. You can use these formulas here. Generally speaking, I don't need them. You can do them by sight, and we'll talk about them in a sec. So here's our first one here. What we're going to do is sketch this function. So the way we're going to do it first of all is just change the form a little bit. 2 brackets t take pi on 4. Okay, so we're going to note that the transformations are a dilation factor 2 from x. It's a translation pi on 4. So translation pi on 4 units right, and it's a dilation factor. And remember, it's going to be that if that's our n value, it's going to be 1 on n, so 1 on 2, factor half from y axes. All right, let's put axes there. Okay, so let's go ahead and sketch it. Now, again, there's heaps of different ways of sketching trig functions, and I'll show you the way I sketch these ones. So what I do is I really, in essence, forget that there's a translation first of all, okay? So I'm going to actually sketch y equals 2 sine 2t first of all, and then I'll show you what I'll do with the translation. Okay, so here it is. I've got an amplitude of 2, a period of 2 pi on 2, which is pi, and a scale of pi on 4. Okay, so here goes. What I'm going to do now is sketch 2 sine 2t. So I'm going to put a point there, a point there, a point there, a point there, and a point there. Now I'm going to note that it wants this sketched between pi on 4 and 5 pi on 4. Okay, so what's going to happen with each of these points once I translate them? I'm noting that this is a translation pi on 4 units to the right. So what I generally do is have a different color, and I grab this point here and I move it to here. So that point moves to there. That point is going to move pi on 4 to the right, so that point goes to there. That point will go to there, and that point will go to there, and that point will go to there. So all of those points will move after they're being translated. Now what I do is I sketch my curve. So I just sketch the one cycle. Then I check the domain, which is pi on 4 to 5 pi on 4, and that's convenient. We've basically got that sketched. Okay, so pop in your endpoints, 5 pi on 4 comma 0, and pi on 4 comma 0, and your max and mins and your x-intercepts. So we've got pi on 2 comma 2, pi comma negative 2, and this x-intercept is 3 pi on 4 comma 0. Okay. So there's the basic process that I use is I first of all sketch the untranslated version, and then we'll just translate the points the given amount in the question. All right, let's have another look at a different question. So sketch cosine x take pi on 4. Okay, so so our period, our amp, and our scale is going to be, period is 2 pi, amp is 1, and scale is 2 pi on 4 equals pi on 2. Okay, so this is cosine, so what I'm going to do is pop 1 point there, 1 point there, 1 point there, 1 point there, and 1 point there. Okay, now what I'm going to do is the shift, and it's pi on 4 units to the right. Okay, so what I'm going to do is grab each of these points. Okay, so here's pi on 2, which is 2 pi on 4. This point here is going to be pi on 4. So that point there is going to move to there. That point there is moving to there. That's going to move to there. That one moves to there. And this one moves here. So what's going to happen is basically we're going to go like so. Okay, and like so. All right, so what are we going to include? Well, now we have to include a y-intercept, and we have to include this endpoint here. Okay, so we've got to include the max and mins as usual and the x-intercepts, but they're no trouble. So that's a problem and that's a problem. I wouldn't have a clue what the intercepts are. So let's get the y-intercept first of all, which occurs when x is equal to 0. So to do that, we're going to go f of 0 equals cosine of negative pi on 4. Okay, so we're going to grab the cosine of negative pi on 4. So what we're doing is starting here and going down to there. Cosine of pi on 4 is going to be, negative pi on 4 is going to equal 1 on root 2. Okay, now let's just see if that is roughly right. That's 1 on roughly 1.4, which is like how many times? That's 1 over 1.5, 1 over 1.5, that's 10 on 15, that's 2 on 3, 2/3, or roughly, so this is me just approximating here, 0.6. So here's 0.2, 0.4, 0.6, looking pretty good. Okay, it's looking like, yeah, that seems to be the right value. So let's label our y-intercepts now. So when x is 0, y is 1 over root 2. Our maximum, pi on 4, comma, not 0, pi on 4, comma 1. This one here, our x-intercept is 2 pi, that's going to be 3 pi on 4, comma 0. This one here is going to be 4, that's 5 pi on 4, comma negative 1. This x-intercept here is going to be that 6 pi on 4, that's going to be 7 pi on 4, comma 0. And this value here, so I could do f of 2 pi, but what will happen is we've just gone a full way around the unit circle from here. So we're back to actually this value here. So this is actually going to be 2 pi, comma, the same exact value, 1 over root 2. And you can do that by yourself if you want, and you'll find that that is the exact value when I slam in 2 pi. So it's going to be 1 on root 2. F of 2 pi is going to be 1 on root 2. Right, so there's all endpoints with coordinates and other key features. All right, what's next? All right, this is hideous. Okay, so this one is going to take a while to explain, so settle in while I go through this one. Okay, so the first thing is that I'm going to sketch some guidelines as to how I'm going to draw this. Okay, so this is a translation. So remember, this value here on the cosine function will send the function either up or down that many units. So this is going down negative root 3. So negative root 3 is roughly negative 1.7. I'm going to go here and go 1.2, 1.4, 1.6, 1.7 is there. And what I recommend you do is we just get a mean line drawn. Okay, so draw that mean line in pencil. Okay, so that's going to be the average, and so cosine is just going to go like that. Now, what's the amplitude? The amplitude is 2. Okay, so what it's going to do from the mean line is go down 2 and up 2. So down 2, that's negative 1.7, negative 2.7, negative 3.7. Somewhere around there is going to be our lower limit. And So this is negative 1.7, negative 0.7, and over to here, what's that? That's like a 0.3 or something like that. Okay, so let's draw that line in. Whoops. Okay, so that gives us the overall sort of template for how we're going to draw it. Okay, now we've got a period. So let's do our period calculation. So period for a cosine function is 2 pi, and we're going to go over 2, which is pi. And then our scale is going to be pi on 4. Okay, now what I'm going to note also is that later on I'm going to have to shift this pi on 3 units to the right. Okay, now pi on 3, where our scale is pi on 4, does get a little bit messy. So here's what I'm going to do with the scale. This is a strategy that I like to use. I'm going to rewrite the scale as 3 pi on, not 4, 3 pi on 12, which is exactly the same as pi on 4. I'm going to write the shift, the translation, as, instead of pi on 3, I'm going to write it as 4 pi on 12 right. And now that I've got this, what it allows me to do is to actually label my x-axes with the scale and allow for the translation to be matching the scale. All right, so to do this, you need to write small. I'm going to zoom in a little bit and label my x-axes as follows. So this is going to be pi on 12. This is going to be 2 pi on 12 or pi on 6. This is going to be 3 pi on 12, which is pi on 4. It can help to put, so I'm going to just actually put 2 pi on 2 pi on 12, 3 pi on 12. This is 4 pi on 12, which is 2 pi on 6. What do we got? 5 pi on 12, 6 pi on 12, which is pi on 2, 7 pi on 12, 8 pi on 12, which is 2 pi on 3, 9 pi on 12, which is 3 pi on 4, 10 pi on 12, 5 pi on 6, 11 pi on 12, which is just 11 pi on 12, and 12 pi on 12, which is just pi. Okay, so you can see even labeling this is a bit of an effort. All right, now let's zoom out. All right, so the way the function is going to work, so let's forget that it's been translated. And what I'm going to do is put some points in. So the points are going to go as follows. Cosine is going to start up here, somewhere up there. And then the scale says it's 3 pi on 2. So here's 3 pi on 12. So 3 pi on 12 is there. So it's going to hit the mean line. Then it's going to go 6 pi on 12. It's going to bottom out. 9 pi on 12, it's going to be back to the mean line. And then it's going to be 12 pi on 12, which is going to be at pi. So that's good. That matches the period. One cycle matches the period. Okay. All right, so now what I'm going to do is grab a different color. So I'm going to do this in like fluoro green so I can really see what's going on. And what I have to do is translate all of these points 4 pi on 12 to the right. So here it is at 0, and that point is going to be at 4 pi on 12. It's going to go to there. This one here is starting at 3 pi on 12. It's going to end up at 7 pi on 12, which is there. This one here is at 6 pi on 12. It's going to end up at 10 pi on 12. So you can see here by putting the unsimplified version of it, it actually helps. Well, it helps me anyway. 9 pi on 12, that's going to be 13 pi on 12 there. And pi is 12 pi on 12, 13, 14, 15, 16. That's where it's going to end up. All right, so we can see here that what's going to happen is it's going to sort of go down through there and back up through here, okay? We can see here that we're going to get some x-intercepts as well, okay? And so to get the x-intercepts, what we're going to do is solve it and let y equal 0. I'm going to say 0 equals 2 cosine 2 x take pi on 3 take away root 3. And that's going to be cosine 2 x take root 3 x over root, why am I saying root 3? Because that's a root 3, equals root 3 on 2. Okay, so when is cosine root 3 on 2? It's going to be at, so I just know that the cosine of 30 is root 3 on 2. That's going to be pi on 6, and it's going to be here as well. So they're the two spots where it hits the root 3 on 2. So that's going to be 11 pi on 6. Now, here's the really tough solve here. So what we've just done is solve this, and we're saying 2 x take pi on 3 is equal to pi on 6 and 11 pi on 6. Now what we've got to do is just bust this up. So I'm going to divide by 2. So go down the page a little bit more. And I'm going to say x take pi on 3 is equal to pi on 12 and 11 pi on 12. And I've just got to shift them, and that's the same as if I multiply that by 4 and multiply that by 4, both of those have got to have 4 pi on 12 added to them. So that's going to be 5 pi on 12, and this one is going to be 15 pi on 12. So let's go find those two locations, 5 pi on 12, which is there, and 15 pi on 12. So there's 12, 13, 14, 15. And look at that, like the symmetry is just perfect. Okay, so you can see here that the x-intercept falls one like kind of scale factor or 1 unit to the right of it, and over here the x-intercept is 1 unit to the left of it. So I reckon we're ready to sketch one cycle of this thing. So I'm going to again switch up my color. And remember, what cosine does is it'll sort of go like that. All right, so now what you can do is kind of use the symmetry to predict what's going to happen. All right, so let's go back to that fluoro green color, and I'll continue plotting x-intercept. I just know that if it goes down there, the symmetry says it's got to go through, or another of the x-intercepts is pi on 4. Now notice I didn't get that one, but I didn't really care because I knew that as long as I got 2 in there, that I could use the symmetry to kind of get everything else sorted. So it's going to have another x-intercept there. And what it's going to do basically is go down, and scale is every 3 pi on 2. So here is 4 pi on 12. So at pi on 12, it's going to hit this point here, and it's going to have a y-intercept somewhere over there. Okay. All right, so what is well, let's keep going on this side as well. So here is, that's going to be 15, that's 16 pi on 12. This one here is 17, so 3 more than that using the scale factor. So we've got 1, 2, no, 3 more than this. So it's going to be 1, 2, 3. It's going to be there. Might just go in and label this. So I'm just going to zoom back in and finish off the labeling. So switch over to red. That's 12 pi on 12. This is 13 pi on 12. This is 14 pi on 12, or 7 pi on 6. That writing is 7 pi on 6. This is 15 pi on 12. So 15 pi on 12, which is 5 pi on 4. 16 pi on 12, which is 4 pi on 3. 17 pi on 12. This is 18 pi on 12, which is 9 pi on 6. Oh my goodness, which is 3 pi on 2. So that's 19 pi on 12, 20 pi on 12, which is 10 pi on 6, which is 5 pi on 3, 21 pi on 12, which is 7 pi on 4. Almost there, almost there. It's 21, this is 22 pi on 12, or 11 pi on 6, 23 pi on 12, and yay, we've made it 2 pi. Okay, so 16, 17, 18, 19, there's a point there. And let's go back to green. So point there, then there's 22 pi, that's down here. And it'll be 25 pi, it'll get back to here. So it's going to stop short somewhere along this line here. All right, let's go ahead and sketch this up, or sketch what we've got, and start to then fill in some of the other blanks. All right, so back to blue. Okay, so we had it rounding out and going through there, and it's going to come down through that point there and end up somewhere there. Okay, it's going to go down to here, come back up, and it's going to head towards that point, but it's going to stop short. It's going to stop short there. Whew. Okay, so we need to get these endpoints, okay, and we need to label all of the other key features, okay. So we'll start on that in a sec. Let's get the other y-intercept, or get the y-intercept. So the y-intercept occurs when x is equal to 0. So y equals 2 cosine 2 negative root 3 take root 3. Okay, so let's do the y equals 2 cosine negative 2 pi on 3 take root 3. All right, so what is the cosine of that? We're here on the unit circle, and pi on 3 means that cosine is a half there. So that's going to be negative a half. So that's y equals 2 times negative a half take root 3, which is equal to negative 1 take root 3. Now negative 1 take 1.7, so there's negative 1, take away 1.7 will be somewhere down there. So I've sort of cheated a little bit, we're somewhere down here, okay? And we're going to label that with its exact value, which is when x is 0, y is negative 1, take away root 3. All right, now what will happen over this side is, because we've got this symmetry here, we're going to have, when x is 2 pi, y is also going to be negative 1 take away root 3. All right, now we can start to label our intercepts. So this is pi on 4, 0. This is our maximum value, which is going to be 4 pi on 12 is pi on 3. What did I write that as? Four pi on 12. I wrote that as 2 pi on 6. That's smart. That's pi on 3. Okay, so pi on 3, comma. Now this value here is the mean line, which is negative root 3 plus whatever the amplitude is. So it's that. So negative root 3, which is roughly negative 1.7, plus that 2 on top of it. Okay. All right, now that's that point there. This is going to be, what's that? That's 5 pi on 12, comma 0. All right, this one here is going to be 10 pi on 12, or 5 pi on 6, comma. Now it's the mean line, negative root 3, and we're going to remove 2 from the mean line to get to the lowest level. These values here will be the same as these values, albeit with pi added to it, okay? And so make sure you fill in your notes for those ones there. And then finally, this last one here, we've already done that one. Now that's absolutely the nastiest possible sketch you can ever get, all right? I've never seen anything even remotely close to something like that on a VCAR exam. Remember, there's only one graph sketch that you're expected to do, and that's in exam 1, and it wouldn't be this, okay? So why do it? Well, if you can sketch something like this, you can sketch anything, okay? Any trig function, you'll be able to sketch it. So they're just fantastic practice. It'll take ages. This one's probably taken me the best part of 15 to 16 minutes. But it's time well spent when you think about how you're thinking about the translations, how you're working the fractions, how you're doing some solves on this. All of those things are really, really important skills, okay? All right, so the work will be, there's going to be another video. I'll do a separate video on transformations, but the work will be down here. It'll be those questions there, 6F and 6G, okay? So another video, I'll record the other video separately on the transformation.